Now we are going to discuss question number 1.20. In this question it is given a point charge causes an electric flux of minus 1.0 into 10 to the power 3 Newton meter square per coulomb to pass through a spherical Gaussian surface of 10 centimeter radius centered on a charge. Okay, fine. Our objective here, if the radius of the Gaussian surface were doubled, then how much flux would pass through surface? Clear? So now concentrate on a screen. A point charge causes a flux. So value of finite, this is given. This is negative of 1.0 into 10 to the power minus 3 Newton meter square per coulomb. Clear? Now spherical Gaussian surface and radius is given to you 10 centimeter. Okay, fine. If radius of Gaussian surface were doubled, so let's suppose we are having point charge, and let's suppose this is Gaussian surface we are assuming. Let's suppose this is Gaussian surface. Clear? At this time we are having radius r. Now in this question it is given to you value of r doubled, then how much flux would pass through surface? It means, now what is situation? Listen carefully, I am again drawing this diagram. So let's suppose I am taking, this is a point charge q. Let's suppose initially we are having Gaussian surface like this, having radius r. Now let's suppose radius double. So when radius double, let's suppose it becomes like this. Yes or no? And let's suppose this is twice of r. Clear? Our objective in this question is to find how much flux would pass through surface when its radius double. Clear? So actually we know value of phi, this is given by E dot A. Clear? So if we take any cross section, we can say E and A both are in the same direction, because this is a negative charge, so we can say electric field lines is going in this direction. Yes or no? Or we can say area vector is outward direction. Clear? So we will find same situation at each point. Clear? So we can say here we are getting negative phi equal to minus A. Clear? But important part we can write like this, kq divided by r square, and we can also write like this is 4 pi r square, because cross section area we are having 4 pi r square. Yes or no? But this is at position, we can say when we are talking about Gaussian surface 1. When we are talking about Gaussian surface number 2, what will happen? We can write like this. Now let's suppose phi dash. Clear? We can say minus kq divided by twice r whole square multiply, we can say 4 pi twice r whole square. Clear? So we can say twice r square cancelled out. It means we can say we are getting phi dash, this should be equal to phi. A very important conclusion we are getting here, whenever we are changing radius of a Gaussian surface, but q net that is inside this surface, inside this Gaussian surface is same, we can say net flux that is coming outward or inward, it always remains same. Yes or no? It does not depends on a radius of Gaussian surface. Clear to everyone? So what is answer of option number A, part number A? How much flux would pass through the surface? Same flux will pass through this surface. Clear? So our answer will be, this is equal to minus 10 to the power 3 Newton meter square per coulomb. Clear to you? Yes or no? Now if we talk about B part, what is value of point charge? So we can write like this, q by epsilon naught, this should be equal to we can say 10 to the power 3 Newton 10 to the power 3, because this is value of flux. Clear? Here we are taking minus because it is given in a question. So we can write like this, q, this should be equal to minus 10 to the power 3 8.85 into 10 to the power minus 12. Clear? So from here we can write like this, minus 8.85 into 10 to the power minus 9 coulomb. Clear? Or you can write like this, minus 8.85, this is nanocoulomb. Clear to you? Definitely we will get here negative charge, because for the negative charge electric field lines always come inward direction. Yes or no? And flux is given to you negative, it means this is inward flux. Yes or no? So value of q we are getting minus 8.85 nanocoulomb. Clear to everyone?